Welcome to part 5 of our semester 1 review packet video. Number 21. We want to write a quadratic function. We're given the vertex and another point on the parabola. So vertex form of a parabola is very helpful. Make sure you have that in your notes if you haven't already. So h and k are the x and y coordinates of the vertex. So -2 is our h, and 5 is our k. I'm going to go ahead and plug those values into my equation. So I get x plus 2 squared plus 5. So the only thing that's not in our equation that we need is a. So we can plug in the point and solve for a. So we see that y is 9, so 9 equals a times 0 plus 2 squared plus 5. 2 squared is 4, so we get 4a plus 5. And then we solve for a. And we get a equals 1. Now since a equals 1, we're not going to write it. It's just implied that it's there. So we get y equals the quantity x plus 2 squared plus 5. Number 22, we want to find all the real zeros. Okay, so this one is factorable, although not all cubics will be. We look at the first two terms, we can factor out x squared. And what we have left is x minus 4. And then we can factor out negative 25. And we get x minus 4. So, in factored form, we get x squared minus 25. And x minus 4. Once it's fully factored, we can go ahead and set each factor equal to 0 and solve for x. So we get roots of 5 and negative 5. And 4. So those are our zeros. On the calculator, if we graphed it, x cubed minus 4x squared minus 25x plus 100. And if you zoomed in, use the zero function, you'd see that those 3 zeros agree with our answer that we did algebraically. Now on the test, there may be only one rational zero, in which case you'd have to use division to get it to a quadratic, and then possibly use the quadratic formula. Number 23, we're trying to find any relative extrema, relative minimums, and maximums. Since we're approximating, we're going to go ahead and use our graphing calculator. X cubed plus 3x squared minus x plus 6. Oh, Mr. Purcell made a mistake. Hold on. He misread the equation. Let's go back You probably noticed that and said, Mr. Purcell, you messed up. Well, it's x to the fifth plus 3x cubed minus x plus 6. Now that matches the equation. So we'll try it again. We'll push graph. And it appears that there may be a peak and a valley somewhere around here. So let's zoom in. I like the zoom box. And with this window, I can clearly see the relative maximum and minimum. So we'll start with the relative maximum. So second trace, I'll go to maximum. For my left bound, I need to be to the left of the peak. And for the right bound, the right of the peak. Pushing enter when it says guess. And I have my relative maximum. Then for the relative minimum, I'll once again go to second trace. I'll choose minimum. Left bound, right bound, guess. And so my relative minimum occurs at 0.324 and 5.782. Number 24, find a polynomial function that has the zeros 4, -3, 3, and 0. So recall that if a is a 0 of a function, then x minus a is a factor. So I'm going to write the factors. 0 of 4, x minus 4. 0 of -3, x plus 3. And then for this, I could write x minus 0, but I'm not going to. I'm just going to write x. So now I need to multiply all four factors together, and that will give me my polynomial. Now to make things a little easier, I'm just going to move the x to the front, which I can do because multiplication is commutative. There I get x squared minus 4x. I recognize this difference of two squares. That's x squared minus 9. If you didn't know that, you could FOIL it. You'll still get the same answer. So x to the fourth minus 9x squared minus 4x cubed plus 36x. Now normally we wouldn't write it, this is our final answer, because we like things in descending order. So the best answer would be written as x to the fourth minus 4x cubed minus 9x squared plus 36x. To check, we'll just go ahead and plug in the equation into y1. And then we'll graph it and see if it does have zeros at 4, -3, 3, and 0. Remember, Zoom 6 gets you back to the standard viewing window. Okay, well, -3, 0, 3, and 4. So it looks good. Okay, number 25, divide by using long division. Okay, so first step, I divide the leading term by the leading term of the divisor. 4x cubed divided by 4x is 4x squared. Then I go ahead and multiply that out. I'm sorry, I just spaced out there. Let's try that again. 4x cubed divided by 4x is x squared. There we go. 2 mistakes in one video. Shame, shame. So I'll multiply x squared by the 4x plus 5, and I get 4x cubed plus 5x squared. I subtract, and I get negative 12x squared. I'll bring down the negative 11x. Negative 12x squared divided by 4x is negative 3x. So I multiply. Negative 12x squared minus 15x. And then I subtract. Negative 11x minus negative 15x is 4x. 4x divided by 4x is 1. And this one, we have no remainder. So x squared minus 3x plus 1 will be our quotient. Number 26, solve for a and b. Now, we're assuming that a and b are real numbers. Otherwise, this problem has many solutions. So if a and b are real numbers, then I know that the a plus 6 part has to equal the 6. And the 2bi part has to equal the negative 5i. So now we just solve for a and b. A is 0. And b is negative 5/2. Well, that's it for part 5. We'll pick up with problem 27 on the next video.